Bismillahirrahmanirrahim. I formally welcome you all to this mathematics class for bioinformatics. Today topic is basically the continuation of the last lecture where we have done how to find the eigenvalues and eigenvectors. So like any other topic, so the key questions that must come to your mind as a researcher and as a student, that why we need this topic. And then the question is this, how we will do that topic, means how we will solve it. Okay, so why we need this, or what is this topic, and how we will solve it. The next part, how we will solve the eigenvalues and eigenvector, has been done in the previous lecture. So today we are more interested in a question that some students has already asked me, that why we need this topic. So what is so important in this content that we are learning this in a MS Bioinformatics program. Okay, so let us see. So I am going to write a question here. So why we need eigenvalues and eigenvectors. This is question number one. Question number two is this: what is eigenvalue and eigenvector? And the third question is this: how to find these eigenvalues and eigenvectors. Okay. So for the solution of these three questions, we have answered question number 2 and question number 3 in the last lecture. Just to write you that what was the eigenvalue? It was the number which satisfies this equation, where this A was a matrix and lambda is any scalar K, and this K can be a real number or even a complex number as well. Okay, so this was just what is eigenvalue. So how to find it? So you remember, we have defined a characteristic equation: A minus lambda I is equal to 0. And if we solve it, so what is going to happen? We will find the lambdas, and that lambda will be our eigenvalues. This is what we have done in the previous lecture. So now the most important part is that why we are finding these eigenvalues and eigenvector in this MS Bioinformatics program. Okay, so let me answer this here. So the idea is this: if you see this model here, in the last lecture we have seen that the population is represented by the formula in time variable xt plus 1 is equal to matrix time that vector, and that matrix is actually the population matrix or the projection matrix. Okay, so we are going to see that the projection matrix rule is actually the same as the scalar rule. So instead of multiplying or operating this matrix to the vector, it is the same like we operating or multiplying a scalar to a vector. So instead of doing this whole task, we are just interested in finding the scalar, and this will tell that in a future, in certain time steps, what will be the population look like. It will be increasing, it is decreasing, or it is stable. Okay, so let me try to find out what's going to happen. The formula that we are going to establish is written in the yellow color. And what is that? xt is equal to lambda times t into a vector v. So this v vector is actually the eigenvector. We are going to establish this formula. This is our claim or goal. So now what this saying is this? This saying the importance of eigenvalues and eigenvector. Why? On the left hand side, this vector, if you remember the last example, we have two types of trees, A and B. This represents the number of trees in certain period of time. So this is like this vector, and we are finding that after certain time step, after number of like 500 years, 200 years, 10 years, it is actually equal to the eigenvalues to the power this and into the eigenvector. So we can just predict the population means here it is the number of trees in the form of eigenvalues and eigenvector. So let us establish this formula first, that how this has been done. For this you can see table number 1 as well, but if you are having some trouble, you can focus here. So we will start like a time, and we have some vector of time. So in the beginning, if time is 0, so what we will get? X naught. And if for the sake of simplicity we say in the beginning, whatever is the initial guess, this is known. So this is our eigenvector. Whatever is the initial guess, this is a vector, and this is our eigenvector. Let's, for the sake of simplicity, we say this is like this. Okay, now what we are going to do? We are multiplying this by a vector, or sorry, matrix. A x naught is equal to A. Okay, agree? Now you have to be little bit more attentive now. This x naught was nothing but this vector, this a b vector. And what was this a b naught? A b naught means like a x is equal to, instead of x we have, so this will be equal to lambda times vector this. So a b is lambda b. Okay, so far so good, no problem. So what we have done here? So after one time step, the answer is this one. So pay attention to here. After one time step, after one time step, okay, now what about if we have time step 2? Operate A both sides one more time. A V is equal to A lambda B. Agree? So what was AB? What was AB? Lambda B. A lambda B. Okay. So similarly, when we multiply a scalar, it will be a vector. Ax अगर 2 से मल्टीप्लाई होगा तो it will be 2 times of vector, still it is a vector. So what will be this? Lambda of vector. Now instead of vector, what we have here? Lambda vector. One lambda is here. So we are applying this 2 times. So what is here? If you want to make me more, so again A is equal to this one. So now after 2 time step, the formula is, and what this is saying, if T is 2, after 2 time step, lambda power 2. This how this formula has been developed. So what is the essence of this one? What is the final conclusion? That we are able to predict the population after certain time step with the help of this eigenvalue and this eigenvalue. We don't need much more data. We don't need the multiplication of the matrix again and again. We don't need a square, a cube, a We just need just lambda and eigenvalues. And if you remember the example, so now to save the time, this was our Forest model. This was the matrix given, and we are able to find two eigenvalues and two eigenvectors. What was the eigenvalue? First one 0.98 and other was 1. Corresponding to 0.98, what was the vector? 1 and minus 1. This is what we have achieved in the last class. Okay. So what we predict here according to this formula, if you want to predict a population, you will just write lambda to the power t eigenvector and just write it this way. Because this is a vector, this is a scalar, you multiply this here. Now you can see that after certain period of time, you just need the power of a t. This minus sign is still a little bit problematic, that why this minus sign is present here. But when you go further, you will realize that this is nothing but as the scalar, that this is decreasing. We will see. Okay, now if I want to say after t5, what is the answer? So what you will take 0.98 to the power 5. अगर कोई नंबर 1 से छोटा है और आप उसकी पावर ले रहे हैं 5, तो what will be the answer? Smaller, more smaller. It is like 1 by 2. If it is 1 by 2, 1 by 2 की power 2 ले, 1 by 2 की power 5 ले, what will be the answer? Smaller. 1 over 2 की power 50 ले, answer smaller. So what this is indicating here, that with respect to time, when time is increasing, this population will be, and what this is saying, the same phenomenon. So overall, this is saying that this number of trees, which is actually the first column of that we are going to develop something, it's saying that the first number of trees, which was the A, is decreasing. So this is the whole idea. Okay, so let me go a little bit further quickly. So what was the other vector? The other vector was 5 and 3. This was our V vector. Okay. So if I want to predict the population, what will be that? Sorry, this was the other eigenvector, or what was that? 5 or 3 was the other eigenvector, and its corresponding eigenvalues was 1. This was the other eigenvector, and its corresponding value was 0. If I want to predict first time step, so what will be this lambda power 1? The population in the first time step, lambda power 1, vector 1, lambda power 1, vector 1. So this will be, multiply this by this, this by this, this by this, you will get the population after one time step. Now this is not the complete story. Complete story अभी नहीं है. क्यों? क्योंकि ये तो एक आइगन वेक्टर है, ये भी आइगन वेक्टर है. तो complete story कैसे बनेगी? उसके लिए थोड़ी सी आपको एफर्ट करनी है क्या? Let us say it was 0.9 plus 0.2, 0.8 and 0.5 y and y. This is something. So how you will write this in a matrix form? This xy is xy. And what will be the answer? What will be the coefficient? This was over matrix, whatever is the matrix. What I am saying here, this first column is over eigenvector V1. This second column will be over second eigenvector V2. And their linear combination will tell us what is going to happen in the next time step. How to write a linear combination? C1V1 vector plus C2V2 vector is equal to something. So this is meant by a linear combination. We will study this in detail. Don't worry about that. Okay. सो फॉर एग्जाम्पल अब मेरा ये कहना ये है, मैं ये प्रपोज कर रहा हूँ, अगर मैं ये चाहता हूँ कि मैं वो फॉरेस्ट वाली एग्जाम्पल जिसमें 2 टाइप्स ऑफ ट्रीज थे, एज और बीज, उसको फाइंड करूँ आफ्टर सर्टन टाइम पीरियड, ये मेरा टारगेट है, ये मेरे गोल है इस वक्त। मेरा कहना ये है कि वो जो नंबर ऑफ ट्रीज हैं वो कुछ भी नहीं है सिवाय इसके कि वो जो आइगन वेक्टर आपने निकाले हुए हैं वो उसका लीनियर कॉम्बिनेशन होंगे। इसका क्या मतलब? इसका मतलब ये है कि जो आइगन वेक्टर आपने कैलकुलेट किए हुए हैं, दिस इज रिप्रेजेंटिंग समथिंग मींस डायरेक्शन, यानी डायरेक्शन कितना, और सॉरी किस तरफ। और नेक्स्ट क्वेश्चन रह गया कि वो कितने, हाउ मेनी, दिस वी हैव टू फाउंड। Direction is clear with respect to eigenvector. If you remember what was the eigenvector, it is representing something like a direction. Now the question is how much, कितने हम values लेंगे, this we will find. अब इसको उधर tricky part है, कैसे? ये जो बात है इसको मैंने explain कर दिया है यहाँ पर। अगर आप focus करें 15 seconds के लिए, for example, मेरा कहना ये है कि ये beginning में initial guess, शुरू में इनिशियल गेस तो गिवन होगा ना, लाइक इफ यू रिमेंबर नंबर ऑफ ट्रीज जो ए टाइप के थे वो कितने थे 10, और बी टाइप के कितने थे 9 ऐसे ही था ना। अच्छा, मेरा कहना ये कि शुरू में अगर ये है तो मैं देखना चाहता हूँ कि इस डायरेक्शन में और इस डायरेक्शन में C1 C2 क्या होगा। तो मैं क्या करता हूँ, मैं इसको मैट्रिक्स वेक्टर फॉर्म में लिखूंगा। ओके, वो क्या है, अगर C1 होगा तो C1 इससे मल्टीप्लाई होगा C1 इससे भी, तो इधर क्या आ जाएगा 5C1 3C1, इधर क्या आ जाएगा C2 माइनस C2। अब 5C1 प्लस C2 फर्स्ट रो आ जाएगी। इसी तरह इसमें क्या होगा 3C1 माइनस C2, इसी तरह की रो आ जाएगी। अब इसको मैं दोबारा मैट्रिक्स वेक्टर फॉर्म में बिल्कुल इसी तरह लिख सकता हूं। देखिए यही लिखा हुआ है, क्लियर हो गया स्टेप। मैं क्या करना चाह रहा हूं, मैं चाह रहा हूं कि वो कितने C1 C2 कैसे निकालेंगे। अब जरा मुझे आप बताएं कि अगर आपके पास यहां पे लिखा हो A0 B0 और यहां पे मैट्रिक्स गिवन है 2/2 का, और यहाँ पे वो वाला वेक्टर है जो आपने फाइंड करना है। सो व्हाट विल हैपन, यू कीप दिस वेक्टर ऑन द लेफ्ट हैंड साइड C1 C2। अब क्या करें, ये मैट्रिक्स है, तो अगर मैं इसके इनवर्स से बोथ साइड पे मल्टीप्लाई करूं, इसके इनवर्स से, तो व्हाट विल हैपन, जो भी ये मैट्रिक्स है इसका इनवर्स और साथ में ये वेक्टर पड़ा होता। Now, if the inverse of this matrix exists, we multiply this with the initial data, we will get C। ये वेक्टर हम फाइंड कर लेंगे, तो ये इक्वेशन सेटिस्फाई हो जाएगी, वो कितने थे वो हम फाइंड कर लेंगे। So this is something like a new thing for you, and if you want to know the complete picture, then this whole question is solved here. So this was our matrix, तो आपने क्या करना है, इसका इनवर्स फाइंड करना है। तो व्हाट इज द इनवर्स, adjoint or determinant। If you find the determinant, it will be -8, this is the adjoint, simplify, you will get C1 C2 125 and -615, so this is over C1, this is over C2। so what we conclude that the initial population is now represented by the eigenvectors। तो वो जो आइगन वेक्टर्स हम कैलकुलेट कर रहे हैं, आइगन वैल्यूज कैलकुलेट कर रहे हैं, इससे हमें मैट्रिक्स मींस सॉरी जो पॉपुलेशन है उसका पता चल गया, और आफ्टर सर्टेन टाइम कितना होगा उसका भी पता चल गया। अब पूरी पिक्चर को देखते हैं। हमने शुरू में सिर्फ एक वेक्टर लिया, यहाँ पर तो 2 टाइप्स के ट्री थे, 2 आइगन वेक्टर थे, ठीक है। तो हमने उसकी मदद से ये वैल्यूएट भी कर लिया। अब अगर मैं ये चाहता हूँ कि दोनों आइगन वेक्टर की मदद से ये प्रेडिक्ट करूं कि आफ्टर सर्टेन टाइम पीरियड कितनी पॉपुलेशन होगी नंबर ऑफ ट्रीज ए की, नंबर ऑफ ट्रीज बी की, उसका फार्मूला क्या होगा। वो जो फार्मूला हमने एस्टेब्लिश किया था, दिस इज लाइक ए वन वेक्टर, बी वेक्टर क्या था, वन वेक्टर था ना, तो उस लैम्डा की पावर टी थी। यहाँ पर कितने आइगन वेक्टर हैं? So what will be the formula in that case? This is now our next objective. Okay. Now there is a small theorem. I will just go in the bottom here. So this is just a simplification. Simplification of what? The table like this. You multiply A, you will get lambda B. You will get another lambda square. You just write the linear combination. Operate again and again. After a certain time period, you will get this formula. Similarly, what was the first part? Lambda 1t for vector b. If you have two vector, what will be the formula? This one. If you have n vector, what will be the formula? This whole line. So if you pay attention, अगर आप 1-2 मिनट के लिए बल्कि सिर्फ 5 सेकंड के लिए इसको देखें, you will get easily understand कि अगर हमारे पास सिर्फ एक वेक्टर था तो xt means the population was c1 lambda to the power t b. Finish. If you have two vector, दो वेक्टर आ जाएंगे, तीन होंगे, तीन आ जाएंगे. So let us do this example of two trees and apply this here. क्योंकि हमारे पास two types के trees थे, A और B, तो हमारे पास दो आइगन वेक्टर आए थे, तो हम देखते हैं कि वो क्या सिनेरियो बनेगा. Oh, so this is something like almost the last part. Actually, so what is the example? It says that for the population used in the numerical investigation of the forest model, we have already seen that the initial data is 10 and 990, and this can be written as, in the previous example, C1 V1 vector minus C2 V2 vector. ठीक है जी. अब हमारा क्वेश्चन क्या है कि ये क्या रिप्रेजेंट कर रहा है आफ्टर सर्टेन टाइम पीरियड ऑफ टाइम. सो व्हाट आई एम डूइंग इज देयर. सो C1 lambda to the power t plus C2 lambda to the power t. This is V1. तो बिल्कुल उसी तरह ये 1 की पावर t है ना, इधर देखिएगा, इधर इसको इससे मल्टीप्लाई करें, इसको इससे मल्टीप्लाई करें, ये आ गया, स्ट्रेट फॉरवर्ड है. अब ये -615 इंटू दिस है, इसको 1 से मल्टीप्लाई करें, इसको -1 से, ये आ गया, और दरमियान में क्या है. तो ये सिमिलरली जो लाइंस यहाँ भी लिखी हुई थी वैसे सम आ गया. अब आप थोड़ा सा इसको सिंप्लीफाई करें तो यू विल गेट दिस नंबर. नाउ व्हाट दिस नंबर इज सेइंग अगेन. अब ये नंबर ये कह रहा है कि याद है ये वो पॉइंट थे जब फॉरेस्ट इक्विलिब्रियम में था, 625 and 375. अब ये क्या कह रहा है? ये कह रहा है अच्छा शुरू में या उसका इक्विलिब्रियम पॉइंट तो ये है, सो वी मल्टीप्लाई दिस फैक्टर into this factor, we will get the next population of number of trees. If you put T1, इसको T1 0.9 की power 1 में 615 से multiply करें, 6 में minus करें, you will get a population of number of trees after one time step of species A. इसी तरह इसकी आती है. So this is the whole picture, and here I stop here. And I wish that this was a good beginning for us to have video recording. Thank you.